were solving equations in equation land. We were solving quadratics, which are equations with powers of 2 for the highest power. And today we're looking at radical equations. So these would be equations that the radicals are in. And we want to be able to solve them in radical form, or if we're using exponents as well. Oh, I need pens. I don't have any pens. It's really hard to do this without pens in my hand. All right. So we are solving radical equations. All right. All right. Be able to solve nth root equations in radical form. And so it's really important that we have two things to remember today. First of all, as a reminder, when we're solving equations, we're looking for two things, really. We're either solving something where we're finding where it's equal to 0, so we're finding the x-intercepts, maybe, okay. Or maybe we're looking at functions, and these are little square root swoop graphs, and we're seeing where these two functions intersect, all right? So when we're solving, we're either finding intersections of two curves, or we're finding x-intercepts, depending on how that equation is set up. So today we're going to start with these couple. Those are wrong page. There we go. Turn to page 2. Here we go. All right. So here we have the first type here. I'm going to do a lot of skipping around today because it's a lot of questions here. Eliminate the radicals by squaring or cubing, etc. on each side, and then we solve the resulting equation. And here's the super important part. What we're doing when we square both sides is we end up creating an extra solution sometimes, okay? Because potentially, what you'll see here, we could be multiplying another x in there when we're squaring something. And so it creates an extraneous solution, a false solution. So you do absolutely need to check your answers to make sure that they are valid. So here you can see type 1 here. We have a radical equal to radical. This is the easiest kind. I can't solve when everything is trapped underneath a radical. So the easiest way to get rid of that is to square both sides. And the square and the square root undo one another. So we get a nice, super simple 3x minus 20 equals 24 minus x. Squaring both sides cancels out the radical, and it's a super easy equation to solve. Let's see, I'm going to add the x, so that gives me 4 x's, and I'm going to add the 20, so that gives me 44, which means x equals 11. Beautiful. Now, I want to check my answer, and I can do it a couple of ways, but I'm just going to do it the easy way right now. I have a giant square root, and I'm just going to plug it back in under my radical. So 3 times 11 minus 20, I get some crazy 3.6055, and I want to plug it in on the right-hand side as well. So I have 24 minus the 11, and I do get the same thing. So I have balance on both sides of the equal, so I know it's correct. Okay, super nice thing that they both work. On number 3, I have a cube root equal to a cube root. How do we get rid of the cube root? Square? Cube, yeah. The cube and the cube root cancel each other out, leaving behind what? Yeah, just the guts of the stuff there. 2 minus 4a is equal to 2a minus 1. And then we can do what? Plus 4a, so it's going to give me a 6a. And then add 1 to the other side, so that gives me a 3. And then divide by 6, which gives me 1/2. Cool. And so I can check that on my calculator. Under the math menu, I have a cube root. and 2. And I always use an original equation. Don't ever use something you've changed, okay? You always have to plug back into the original equation because you might have made a mistake and you don't want to plug back in and check on something that could be wrong. So plugging back in, I see 0 is equal to 0. True or false? True, absolutely true. So that definitely works. All right, so it's really nice and easy when our radicals are separated and equal to each other. Super easy to solve. Type 2 is that we have a single radical somewhere in our equation. We're going to focus on 7 and 8 here. The job is to isolate the radical. Get the radical by itself, and then we can do whatever we need to get rid of the radical. Eliminate the radical by squaring or cubing each side and solve. Always, always check. These are the things you must check to make sure we don't get an extraneous solution. So I'm going to look at number 7. On number 7, what do you want to do first? Divide by negative 9. Yeah, this is negative 9 times the whole radical. So we want to go ahead and divide by negative 9. So we get the square root of 4g plus 13 equals 5. Now our radical is isolated. How do we get rid of the radical? Square both sides. So we can square both sides. The square and the square root cancel out. So we get 4g plus 13 equals 25. I can go ahead and subtract 13, so we get 4g equals 12, which means g equals 3. And again, I just want to plug it back in just to make sure that it works. So I have a negative 9 radical 4 times 3 plus 13, and it does give me negative 45. So it does check, it does balance. All right, on number 8, what do you want to do first? You want to move the 5. That's a good place to start. We're going to subtract the 5, so we get a 2 equals the 4th root of w minus 11. How do we get rid of a 4th root? 4th power. Sure, 4th power on both sides. 4th root and 4th power cancel one another out. 2 to the 4th is 16 equals w minus 11. And we can add 11. So what is that, 27? And so I'm going to plug it right back in and check. 27 minus 11 is 16. The 4th root of 16 is 2. 5 plus 2 equals 7. So it does check out. Always a good idea to double check. Okay. Questions on those? Super easy, no? Okay. So let me show you one. These are the ones you really need to pay attention to. Right here, number 10. On number 10, our job is to isolate the radical. It's isolated. And how do we get rid of the radical? Square. Here's what I'm talking about when we're creating an extra solution. We're squaring both sides. This is x to the first power. The highest power of x tells us how many answers we should have. So this is x to the first power. We should have one answer. By squaring both sides, I've created x squared. An x squared equation says, hey, how many answers are there? 2. But that's a false thing because we didn't start with 2 solutions, okay? And so we have to be really, really careful. We are creating another x by using this method. And while it works, we have to be smarter than our own math, okay? Which means check your answers. Okay, we have now created a quadratic here. How do I solve this quadratic equation? I could subtract x squared, but then I'd have a leading negative. And yeah, I'm going to move We want to set this equation equal to 0 so that we can double bubble. I'm going to move everything over to the right-hand side. So I'm going to get 0 equals x squared plus 7x minus 18. Just so my leading term is positive, life is a lot easier. I'm going to go ahead and double bubble. X times x is x squared. What times what is negative 18? That's positive 18.
Oh, negative 2.
Negative 2 and positive 9, or negative 9 and positive 2 are good choices. And this one, the negative 2 and the positive 9, give us our middle term there, so that's perfect. Negative 2 and positive 9, which means x equals
2 and then x equals negative 9.
Okay, 2 options there. X equals a positive 2 or x equals negative 9. And one of those is not going to work. Plug it back in to check. So again, I'm going to go back in and check my square root here. The square root of, if I plug in the 2, 18 minus 7 times 2. So I'd get 2 equals 2. That's a true statement. But if I plug in the negative 9 to my radical there, then I have 18 minus 7 times negative 9. And I get 9 is equal to, what was my original? Negative 9 was just x there. That is not true. That is false. 9 does not equal negative 9. So that is a false solution there. Just x equals 2x. Yeah.
Question 9.
Mm-hmm.
What would you start with if the life has
Mm-hmm. Good question. So on 9, I would add the 9.
But doesn't divide come before?
So when we're simplifying, when we're solving, we do PEMDAS backwards. Whoops. P-E-M-D-A-S. So we start with any adding or subtracting, and then do any multiplying or dividing when we're solving. So yeah. Mm-hmm. Yeah, good. All right. Let's look at number 11. Our radical is isolated, so how do we clear our radical? Square both sides. Good. What happens when we square this left-hand side?
He becomes squared. So that there's three. It becomes a
Trinomial. Yeah, so this is a binomial square. We have to FOIL. Be very careful. This is p minus 7 times p minus 7. You have to FOIL that out. Do not make that very, very common mistake. All right, so we have to FOIL p minus 7 times p minus 7. What do you get? P squared. Good. Minus 7p minus 7p is negative 14p, and then plus 49. So make sure you FOIL that out correctly. Equals 8p minus 63. Be very, very careful. Now what do you want to do? Yeah, subtract the 8p and add the 63. So let's see, I'm going to get p squared. Negative 14 and a negative 8 gives a negative 22. And then 49 plus 63, holy mackerel, 112. I have no idea what the factors of 112 are. So it turns out the easy way to figure that out is the square root. The square root of 112 is 10.5-ish. So all I need to do is check the factors below that to see. And I can just go through the list. 112 divided by 10? Nope. 112 divided by 9? Nope. 112 divided by 8? Hey! Look at that. There's a winner. 8 and 14. So 112 is 8 times 14, or negative 8 times negative 14. Those are winners, right? Yeah. So p times p is p squared, and what times what gives me 112? Yeah, the negative 8 and the negative 14 is how we get that negative 22. All right, so p equals 8 and p equals 14. Our options, what should we do? Plug them in and check to make sure. So if I plug in my 8, on the left-hand side, I have 8 minus 7 equals 1. And on the right-hand side, I have the, square root of 8 times 8 minus 63. Oh, that was 1. I could do that without my calculator. All right, that one checks out just fine. When I plug in 14, 14 minus 7 is 7 on the left. And on the right, 8 times 14 minus 63, I get 7 as well. 7 on the right, 7 on the left. Both answers check out just fine. Both answers balance. Questions on those? What would you have to do first on number 12? Plus the x over, and then it's the same as 11. So 2x plus 3 equals x plus 2, and then it goes the same as number 11. All right, so only sometimes do we create an extraneous solution. It's really quite interesting. All right, let's look at type 3. So rational exponents, rational fractional exponents. Remember, when we see those fractional exponents, they're actually also radicals. They're just in disguise. Radicals in disguise. So if you saw x to the 3 halves, what is that really? Yeah, the square root of x to the 3rd. So it's really just a fancy radical. Which, if you wanted to, you could trade it around. But actually, the rational exponents is so much easier to use. So we're going to look at number 14. The idea is pretty much the same. We want to isolate whatever that power is affecting, and then we can find the inverse to cancel it out. So here, right now, 1/4 is really a 4th root. So that 2z plus 9 is really under a radical. What do we need to get rid of? The -4. How do we get rid of the -4? Divide by -4. So we get a 3 is equal to 2z plus 9 to the 1/4 power. A 4th exponent, yeah, 4th power. Yeah, right now what we're going to do is we're going to take it to the 4th power. What do you do when you have a power raised to a power? What operation is going on with those? Yeah, it's multiplication. And what is 1/4 of 4? It's just 1. And so the powers undo themselves so nicely. So this becomes 2z plus 9, all to the 1st power, which I don't need to write down. 3 to the 4th is 81. And then we just solve it. So let's say I'm going to subtract 9. 72 equals 2z. And divide by 2, we get z equals 36. And I can do a real quick check again. Back into my original equation, -4, parentheses 2 times 36 plus 9, parentheses, just kidding, to the 1/4 power. So I put the whole thing just as it is there. Oh, it doesn't like that. I put a negative, surely. That is a problem there. Definitely don't want that. Thank you. And it balances. There we go. How about that? So that one checks out just fine. All right, let's do number 16, and then we can call it. What do we do first on 16? Subtract 7. So I have x squared plus 6x to the 3/4 equals 8. And then we need to do what? How do we get rid of a 3/4 power? 4/3, yeah. Reciprocals are real handy here. So we can do everything to the 4/3 power. We should have done 15. Shoot. Think about that. We might have to do 15 too. All right. 3/4 times 4/3 becomes 12 over 12, which reduces to 1, which is super handy. This is why we love rational fractional exponents. And then 8 to the 4/3 It is 16. It's the cubed root of 8 to the 4th power. The cubed root of 8 is 2, and 2 to the 4th is 16. Could you plug it into your calculator too? You absolutely can put that in your calculator, but it is something that's good to know because you're not allowed to on most of the questions on the AP calculus test, but you have to know those things. All right, we can subtract 16. You know what I'm going to do? We're just going to stop right here. And you would double bubble, and you could go from there. This one works out just fine. But I do want to talk about 15 real fast, too. The radical is isolated. So how do we get rid of that rational fractional power? How do I get rid of the 2/3? 3/2? Reciprocal, yeah. So here is the really tricky. This is an even root we are taking. It's like when we have x squared and we have to take a square root of both sides. What do we have to remember when we take an even root? You have two answers, a plus or minus, okay? So because this is 3/2, that is the index. The root is 2. We are taking a square root. So this is really particular. You have two answers, a plus or a minus, because that's a square root, essentially, is what we're taking. Over here, this was an odd root, and this one, we're not taking a root, we're raising it to the 4th power, okay? But here we're taking an even root, so we have to remember that there is a plus or minus there. The square root of 4 is 2, cubed is 8, so there are two possible answers here, plus or minus 8. And that is really, really tricky on those things. Don't forget the plus or minus when you're taking an even root. Okay? So here, this would take two equations here that you'd have to solve. 5v minus 22 equals positive 8, and 5v minus 22 equals negative 8. And then you can solve those from there. And all these answers work out just fine. Okay? Questions for me? All right, cool. You guys have a delta math to do, and I will open that up right at this moment. Hey, 22 minutes, that's perfect.